Welcome to this lesson on Newton's second law of motion. This is one of the most important equations in all of physics. By the end of this video, you'll understand what F equals ma means, and you'll be able to use it to solve real problems. Let's dive in. Have you ever wondered why a heavy truck takes much longer to stop than a small car? Or why you can throw a tennis ball much farther than a bowling ball with the same effort? And why do rockets need incredibly powerful engines? Newton's second law gives us the answer to all of these questions. It connects three fundamental quantities: force, mass, and acceleration. Newton's second law states that the net force acting on an object equals its mass multiplied by its acceleration. If you increase the force, acceleration increases. But if you increase the mass, acceleration decreases. This inverse relationship is why that heavy truck is so much harder to speed up or slow down. Let's examine each variable. F is the net force measured in newtons. 1 newton is the force needed to accelerate 1 kilogram at 1 meter per second squared. Mass m is in kilograms and measures how much matter an object contains. Acceleration is in meters per second squared and tells us how quickly velocity changes. Notice that acceleration is about change in velocity, not velocity itself. The beauty of this equation is we can rearrange it three ways. Need the force? Multiply mass by acceleration. Need acceleration? Divide force by mass. Need mass? Divide force by acceleration. Same equation, three powerful tools. Let's put these to work with real numbers. Here's our first problem. You push a 10-kilogram box with 50 newtons of force. What's the acceleration? We use it equals F divided by m. That's 50 divided by 10, giving us 5 meters per second squared. Every second, the box speeds up by 5 meters per second. That's actually quite fast. Now let's find force. A 1,500-kilogram car accelerates at 2 meters per second squared. Using F equals m times a, that's 1,500 times 2, which equals 3,000 newtons. This is why heavier vehicles need more powerful engines to achieve the same acceleration. Now watch what happens when we apply the same 100-newton force to different masses. A 1-kilogram object accelerates at 100 meters per second squared, extremely fast. 10 kilograms gives only 10 meters per second squared. And 100 kilograms? Just 1 meter per second squared. This perfectly shows the inverse relationship between mass and acceleration. If we graph force versus acceleration, we get a straight line through the origin. The slope of that line equals the mass. A steeper line means more mass. Scientists actually use this in experiments. Apply different forces, measure acceleration, plot the graph, and the slope tells you the mass precisely. Here's a crucial mistake many students make. They think more force means more speed. Wrong. More force means more acceleration, which is the change in speed. An object can have zero net force and still be moving at constant velocity. That's Newton's first law. Force changes motion. It does not cause motion. Let's recap. Newton's second law, F equals ma, connects force, mass, and acceleration. Force and acceleration are directly proportional. Mass and acceleration are inversely proportional. Force causes changes in velocity, not velocity itself. And you can rearrange the equation to solve for any variable. You now have the tools to solve real physics problems. Great job!